All right, this will be my second attempt at trying to do this video. The first time just didn't take. I'm not sure why, but we will try again. So here's one of these simplifying expressions questions using the trig identities, and we're trying to get this cleaned up a little bit, right? It is an identity, and we can use identities to simplify it. So when I look at it, I see really two sections, all righty? I see we've got a cosine, and then we're adding to that sine times tangent. All right, so there's kind of a division there for me with the first expression plus the second. So what I want to do is I want to clean up the second part, this section right here. There's some good stuff I think we can condense and get rid of. So let's go ahead and do that. So inside here, we've got a sine, and let's just get everything in terms of sines and cosines, because we've already got a cosine and a sine, and tangents easily converted to sine and cosine by using your quotient identity, alrighty? So I want you to just focus on this box right here. Focus on everything in here, and let's clean it up first. So we have rewritten tangent as sine over cosine, and since it became a fraction, I feel compelled to make sine also a fraction by putting it over 1. All right, and what that does is that signals to me that we need to get those fractions and multiply them together. Let's clean them up and see what's there. So sine times sine, we write it as sine squared, just like x times x is x squared. But we write it a little weird. We write it with the square in between the sine and the x, signifying that the entire sine value is squared, not just the x, not just the angle squared, but the value of that entire expression is being squared, and that is how we write that. Anyway, so 1 times cosine is cosine, and that stays on the bottom. All right, so look at what you got. This became one fraction now. All right, so what I want you to do now is just step back and look at the entire problem. So now you've got a fraction plus something that's not a fraction. So what do you think we need to do here? Yeah, we need to put a 1 under that thing and then figure out what we're going to do. Well, the question is, what do you do when you're trying to add two fractions and they don't have a common denominator? Oh, goodness. We need one, don't we? We need a common denominator. And this is a very abstract thing. It's not, 1/4 plus 2/5. So let's just think, all right, this has a cosine on the bottom. This one doesn't. But real easily, we could make these two fractions have the same denominator, could we not? And how we could do that is we could just use the rule of how we get a common denominator with just regular old fractions. Let's just multiply it by top and bottom what it needs in order to make these fractions have the same denominator. And if this first one had a cosine, then I'd be good to go. I could add these together and combine them and go on with life. All right, so we got to get a common denominator, and sometimes that is a technique you need to use in order to get this thing going. All right, so what we're going to do is the same thing we did over here. We focused in on what happened when we multiplied those fractions, doing the same thing over here. All right, so now let's focus here and figure out what happens in this little section. Well, cosine times cosine is a cosine squared over cosine times 1 is a cosine. So that condenses to this, all right? Bring down your other fraction here. And again, let's step back and look at the whole thing and figure out what we got. Well, we've got now two fractions that have the same denominator. Yippee skippy, all right? So when you have the same denominator, what do you want to do? Add these two things together and make one fraction. I know it's tempting to maybe want to cancel over here, reduce this. Oh, there's a cosine there and there. I can cancel. Don't do that, because it's going to put you right back where you were, right? We don't want to do that. So let's add these two things together. That's the goal anyway when you're getting a common denominator, because you were trying to add the fractions together. So let's write them as one fraction. So we've got cosine squared plus sine squared, all on the top part of your fraction. That's the numerator. All of that is over cosine. All right. That is the common denominator. And when you combine the fractions, you just need cosine. You don't need two of them. All right. Now, you should recognize something, I hope, and that is what is on the top of this fraction here. That's Pythagorean identity. It really is. Now, it looks in a different format on your sheet, but, addition's commutative. So that means that this is the same as sine squared plus cosine squared. And what is it equal to on your paper? Just a 1. So all of that condenses to a 1 on just the top part of the fraction. One more step here and we'll be done. So if that's a 1 over a cosine, what's a better way to write that? Instead of a fraction, we can write it as a secant using your reciprocal identity. So that right there, friends, that is your answer. And that sure looks a lot better than it did to start with. So finding a common denominator, that's a good way to get these things simplified when and if you need to do that.